Today we just some questions related to asking how to attend the interview and what is the purpose of to attend the interview. What type of question will come that we think? First of all, we define vector space. Vector space. Actually, we just explain about the vector space. Vector space क्या है? क्यों ये क्वेश्चन आएगा? What type of question will come in vector space? So I'm writing here vector space. The vector space is a non-empty set V is called vector space or real vector space if satisfying some conditions. Vector space that represents us, it must be satisfied vector addition. Vector addition and scalar multiplication properties. So just to remember here, vector addition and second property is scalar multiplication property. The vector addition, vector and scalar multiplication, two property whenever it is satisfied, then that is called the vector space. The first of all we discuss about the vector addition. What are the points of vector addition? Vector addition means that is the for any two vectors, for any vectors when we consider case one, any two vectors when consider, suppose u and v are the two vectors of the vector space V, then it must be satisfied here u plus v is equal to v plus u. This is called commutative property must be satisfied, and this is called commutative property. Commutative property. Second point, associative property must be u, v, and w. V R belongs to the vector space. Then it must be satisfied u plus v plus w is equal to u plus v plus w. This is associative property must be satisfied. Associative property. That is the vector. U, V, W are the vectors, U, V are the vectors, and it must be satisfy the commutative property as well as the satisfy the associative property. Then point 3. For U belongs to V. Any vector U belongs to V and it must be satisfied U plus 0 vector, which is equal to 0 plus U vector. That is U. But just to see when you add the 0 with any vector, that is same vector will come, and 0 plus same vector, then that is same vector will come. So this property is called as the identity property. Identity property. Point number 4. Then what is the point number 4? Suppose U belongs to U belongs to a vector space, and same as the case of minus U also belongs to the vector space. For vector addition property, U plus or minus of U, that must be a zero vector. And this is called additive identity properties. Additive identity property. Okay, additive identity property is mostly satisfied. So these 4 points represents as the property of vector addition. And next, scalar multiplication properties are there. Scalar multiplication properties. So what are the points to discuss for the scalar multiplication property? The first point is any two vectors you consider point 1, U, comma V belongs to a vector space. There exists a scalar C, and C is a scalar. And satisfy condition C into U plus V vector, and that is same as the C into U plus C into V, and this is distributive property we satisfy. This is called distributive property for addition. Distributive property. Second point, C and K scalars, two scalars are there. C and K are represent the two scalars. And just here, C plus K into U. Add, this is also distributive property, C into U plus K into U. That is also distributive property is satisfied. So when one scalar, two vectors, you apply the distributive property. When two scalars and one vector, then that is also apply the distributive property of the vector. The next, C, K, and U. These are the scalars. So we can just represent C into KU. Same as the C into K into U. That is the associative property is considered here. Associative property. C into KU plus CK into U is called the associative property. The next property, fourth points. For every U belongs to a vector space, then 1 into U is same as the U. And this property is called as the identity properties. Multiplicative identity property. Multiplicative identity property. You just remember how to, this is the property here, whatever we have expressed here, and if these conditions are satisfied, then that is called as the vector space. Okay. So just now we come to dimensions and basis. Dimensions. The maximum number of linearly independent vectors in V. The maximum number of linearly independent vector. Linearly independent vector That is called as the basis in V. Maximum number of linearly independent vectors is in a vector space V is called dimensions. So basis, what is called as the basis? A linearly independent set V, a linearly independent set V consisting a maximum possible number of consisting a maximum number of possible vectors, maximum possible number of vectors, maximum possible number of vectors. Just remember, linearly independent set E consisting a maximum number of possible vectors is called as basis for V, or the number of vectors of the basis for V is equal to dimension of the vector space. Number of vectors of a basis for V equals to dimensions, or we can say dimension is same as dimension is equal to number of vectors of a basis. Number of vectors of a basis. Okay. So just we discussed here what is the basis, what is the dimensions, and what is the vector space. Okay. Okay, we'll discuss the next. Thank you for everyone.